So yesterday we had discussed about the basic statistical formulas like mean, median, mode, and variance. Also today we are going to discuss. We know the variance formula. Formula is very simple actually. Okay, we are not here to just learn the formula. This is just a formula of, let us say, sum of I is equal to 1 to n number of instances, a number of values, square 1 by n. So let's not worry about the formula. First, understand the concept, then you automatically memorize the formula. It's easy to memorize actually. Okay. What is a variance concept? For example, I have a list of values. For example, 4, 10, 21, and 19, and 7, and 40, and etc. A list of values. So, list of values, what is the variance means? For this, let us say there is a average for these values, the average value. So, what is the mu? Mu is represent the average values, average of these values. Here as average values, for example, let us say I'm not calculating the average value here, but I'm taking some average value here roughly, let us say some 25, let's say average value, let us say just taking average value here. Okay, it may not be right, but I'm just roughly taking for our discussion purpose. Okay, mu 25. So if this is the average of all these values, okay, what is the variance says is how this each and every individual value, okay, how each and every individual value is deviated from the average value. That is what the variance means. If the number of the variance result is high, means all these values are deviated too much from the average value. But how it is important, okay, let's say it's deviated too much or deviated less, how it is important for us, that importance we are going to discuss in the normal distribution and distribution things, actually, not now, okay. But to understand the concept of the variance always tell us how much the each and every value in this list is being deviated or deviated from the average of these values. How to calculate? Let's just take a simple example of here. Let us say I have a data set having some dogs. So, like I have some dog of my and my friend's dogs together, and we are measuring the height of each and every dog. Let's say I have, like, say, some one, two, three, five dogs actually, which is my dog and also my friend's dogs. Total five dogs. Okay, we are measuring the height of the dog. So let us say the measurements, the in millimeters we are measuring. We are noted down five dogs. The five dogs measurements of 600 millimeters. Let us say 470 millimeters and 170 millimeters and 430 millimeters, couple of dogs, and 300 millimeters. So five dogs we have calculated. We have measured the height of the each and every dog. Okay, just for understanding the better the knowledge of the variance. Okay, these are the dogs. So this is what I represented here. We just measured on the each and every dog. This dog 1, 2, 3, 4, 5. We see the red one symbols indicates these are the measurements. So this is the one of the measurement height of the, this is the second dog height, third dog height, fourth dog height, fifth dog height. On the scale of this y axis on the height in millimeters. Okay, so we measured these are the measurements heights of the each and every dog. So what is this average value is, let us say the average value is coming for this one is, let us say, 394. That is exact value. This is, if I say average of these values, it is coming as 394. Okay, you can, I already know, calculated that. So now what is my point is, once I calculate the average value, okay, so I am going drawing a one line. This is my average line, which is a continuous line, and these marks are height of each and every dog. Okay, height of each and every dog. So this is my average of the height of the five dogs. These are the individual heights of the each and every dog. Okay, if I do this, so this is my average line, average height of the five dogs. So these are the respective dog heights. So the first dog whose height is 600 millimeters, average value is 394. This is first dog height is divided. Say how far it is. 206 difference is there between the first dog height to the average of the five dogs. Second dog, there is 76 difference is there between the average of the 5 dogs to the second dog height. Third dog is very shorter, minus 224. So it means it is smaller than the average of the dogs, which is minus 224 is the difference between the average of the 5 dogs to the third dog height. Similarly, fourth dog and fifth dog. Okay. So this is the each and every individual dog is deviated or difference, I can say, difference between the each and every individual dog height to the average of the 5 dogs. That is clear. Okay. So this is what exactly variance. So now this is 206. Okay. Now let us say 394. But variance is calculated something like this. This is my variance symbol in mathematics. The first dog difference 600 minus 394 square plus 470 minus 394 square plus 170 minus 394 square plus 430 minus 394 square plus 300 minus 394 square divided by how many number of dogs? The number of dogs are 5. So this is my value 5. So this is nothing but simply something like this. Let's say 206 square, 76 square, minus 224 square, 36 square, and minus 94 square by 5. That is equal to 108520 by 5. That is equal to 21704. That is my variance. For this data set, is the variance. Higher the variance, what it means? There the values, the each and every dog height is too much deviated from the average of the dog. For example, my data set is something like this. Okay. Similarly, just okay. Let us say 600 millimeters, 592 millimeters, and 610 millimeters or 608 millimeters, and let us say next is 605 millimeters and 595 millimeters. So these are my values. Okay, that's the dog heights. Okay, this is one data set. This is a different data set. Okay, so what is the average value? The average value is coming as okay. All these values divided by sum by number 5. Sum means let us say just calculate the sum. Let us see how much sum it is coming as. Let us just calculate the values. Okay, 600. What is the different values we take? Okay, 592, 608, 592, 608, 605, and 595. So this is sum of all the values divided by 5. So exactly 600. So this is as average is the average mu. Actually, mu value is equal to 600. Now the variance. Let me just calculate the variance. Square is equal to sigma square. And now 600 minus 600 is 0 square. 592 minus 600 is 8. 8 square. I am actually in fact minus 8 square, but it's also minus 8 square. 608 minus 8 square. 605 minus 600 5 square. 595 minus 5 square by 5. So this goes 8 square is 64. 64 plus 25 plus 25. 64 plus 64 plus 25 plus 25. 0 in fact by 5. So 64 twos are 64, I think 128 just, and 25 twos are 50, and this is plus and this plus, this is equal divided by 5. See 35.6 is my variance here. What this see in case of this data set, variance is 21,704. In case of this, the variance is 35.6. What this variance indicates to me is, hey, all the dogs, the dog heights, whatever I just mentioned, some five dog heights, they are very, very close to each other. They are very, very close to each other. There is no much difference between one dog height to other dog height. There is very small differences there. It's very, very small. That is what the variance indicates to me. Small variance means all the dogs are not much deviated from the average of the dog height. That is what it means. Clear so far? The standard deviation, so this number is very difficult to, of course, larger and smaller. I can easily interpret. In case of this one, I can say, yeah, standard deviation. We are going to use this standard deviations is nothing but, let me just erase this. Okay, let me. I can say standard deviation. Okay, standard deviation. Standard deviation represented by just this sigma. Okay, it is equal to square root of variance. This is my variance. So whatever is the value in case of this one, what is my sigma? This is my variance. What is my standard deviation? It is, which is square root of 35.6, having some square root of 35.6. Okay, let me calculate the square root of 35.6 here quickly using the Python. So I'm just going to say import math.sqrt square root 35.6. 5.9 and something. Okay, 5.9. That is equal to 5.96 something. Okay. In case of this, square root of 21704 is equal to square root of 21704. That is equal to almost like 147.32. Well, let's say 147, let us say, just for rounding off. Okay. So this the same concept, standard deviation. So the standard deviation means how much each and every dog height is deviated from the average height of the dogs. Clear so far? So why the standard deviations is important rather than variance? Variance is just indicates okay how much they are deviated. It's a bigger values means they are much deviated, and smaller values means they are less deviated from the average height. The standard deviation is very useful for us when compared to variance. I can say if this is my results, these are my dog heights, and 3 for my average. This is my standard deviation. What I can say, what I can conclude, or what I can able to make some kind of um, insights. I can make it. All dogs, okay, all dogs, which are between the height of mu plus standard deviation to mu minus standard deviations. So mu plus means 394 plus 147 to 394 minus 147. This number is going to come. So whatever is the sum from any dogs from this height to this height, I can say these are a standard height of the dogs. Standard height. A regular height of the dogs, I can say. Okay. And which are less than this height will be shorter dogs, shorter, which are beyond this height, I can say taller dogs. So this is how I can able to make some conclusion. What is the height of the dog? If let's say if this is a given data set, All the dogs between this range, this side to this side, I am considering them as a standard height of the dogs. And whatever is beyond this height, I can say very taller. Whatever is even lesser than this weight is coming as, I am concluding as shorter, very short height actually. So such kind of conclusions we can make with the standard deviations along with the average values. So standard deviations is very important. Variance is just indicates it is the higher number of variance means deviations is much. Lower number of variance means the deviations is small. That is what we can. But the standard deviation value we are going to use it in many places in the distributions actually. So is it clear so far? Variance and standard deviations. Standard deviation. So now let us discuss about the normal distribution. Normal distribution. Okay, normal distribution. So why we are discussing about the normal distribution is we already mentioned in case of our artificial neural networks. Whenever there are some lot of weights connections will be there from one neuron to other neurons. So there are some lakhs of weights will be there. Lakhs of weights will be there. So what we discussed so far during our course is we are going to initiate these weight values randomly. Randomly means there is no logic, so it's a completely random. Any value should come actually. There is no logic. So because of which random initialization of the weights is causing some vanishing or exploding gradients problem we are going to arise. This is a very common problem that we are going to see in case of artificial neural networks. To avoid to fix this problem, what is the recommendation is we have to initialize the weights, but not randomly. It's a like kind of based upon one specific logic. What is the logic is we have to initialize the weights in such a way that the weights, for example, 1 lakh weights I'm going to do input. For example, my artificial and neural network is having only 1 lakh of weights. These 1 lakh of weights, I don't want to initialize randomly. Rather, I would like to initialize them with a normal distribution or uniform distribution. So means my 1 lakh set of data, what are the weights that is kind of 1 lakh set of data, the weights data, they are distributed normally or uniformly. That is what the logic says. If you initialize the weights in such a way, rather than randomly, initialize the weights normally distributed values or uniform distributed values, then this problem will be much reduced. Not completely, may not be completely, but it definitely going to reduce some value. Okay, clear so far? So, what is the characteristics of the, what is the, now, that's why we are discussing about the normal distribution here. Okay, so now the normal distributions. What normal distribution is having some characteristics. Okay, let us discuss about normal distribution things. I'm just going to copy this image here just for our discussion purpose. Okay, fine. So normal distribution means you take some values. So in any distribution, normal distribution or uniform distribution, there are many distributions actually. So concept is for every distribution there must be some logic how the values are being distributed. So we are going to in normal distribution if I want to generate a list of values, a randomly generating list of values, generating some values. Let's say 1 lakh values, 2 lakhs values, how many number of values, it doesn't matter. This is generating a list of values randomly using normal distribution. So means this list of values should follow, this generated or distributed normally. That's what I'm saying. Okay. What this distributed normally means. Okay, understand, this is very, very important. Here I have the two axes, x-axis and y-axis. Okay, x-axis, y-axis. X-axis represents, let us say I am distributing the values between, I have some values between 700 range to smallest value is 700 and highest value is, let us say, 1600, let's say. So I am taking so many values in these randomly generated values. The smallest, I have list of like 700, so many values. The lowest value is 700 and the biggest value is 1600 and so many values. So many values. The lowest value is 700, max value is 1600. So that's why the scale is equal. What is the value? Number of values actually. 700 is my lowest value, 600 to my maximum value. You can choose any value, but I'm giving example of here. 700 is the lowest value, 600 is highest value. So your values can be any lowest value, any highest value. So between this lowest and highest, there are so many values are present in your data set. This is a data set. So this x-axis represents the values of your data set. Y-axis represents how many values are there such value. For example, in my data sets, there is only, let us say, one 700 value. Let us say 1200 value, I have, let us say, some 34, 1200 element, 34, 1200 values are there. Means 1200 are repeated 34 times in this entire data set. That's what it means. 34 values are 34 number of 1200 values are there in this data set. And let us say 1150. So there are 60 number of 1150 values are there. So means in this entire data set, there are 1150 number is repeated 60 times. That's what it means. Okay, understand, it's clear, right? So now this is how many number of how many number of times it is repeated or it is available in the data set. That's what the y-axis indicates. X-axis indicates the values. Y indicates how many number of times the value is present in the data set. How many number of times the value is present in the data set. Clear so far? Okay. So this is my etc. So now what the normal distribution is, I'm going to tell the normal distribution characteristics one by one. Okay. Normal distribution is always symmetric. Symmetric at mean value. Mean value. Let us say I have a set data set whose mean value is equal to, let's a lot of numbers, lot of data sets, whose mean value is equal to, let us say 1150. Mean means average, both are the same. Okay, average or mean, anything is same. So means, see, this is my data set having so many elements are there between ranging from 700 to the 1600. Let's say 850 values, 900,000, so many values are there. In respect to count. See, this is my mu average. This is my average value. For this entire data set, the average value is equal to 1150. So 1150 is my average value. If I just plot the values and the respective number of times the value is present in this data set, in the x-axis and y-axis respectively, I am definitely going to get a curve, a bell-shaped curve, something like this, a bell-shaped curve. So your values are distributed something like this. So means, what does it mean? The mu value, which is 1150 values, are present in the data set highest number of times. This is the highest number of times the data set is present. In the data set, the mu value, the 1150 value is present at maximum number of times, which is, let us say, that is my maximum number of times. So means in this data set, 1150 value has available so many maximum number of times. It can be anything like 100 or 200. What is the maximum number of times? Clear so far? Is this clear so far? And if I just take this graph is, if I just have this one as a one fold here, this is very symmetrical. This is a portion of the graph. This is my one portion of the graph. If I take the average value as a middle, This is my one portion of the graph actually. Correct? And the second portion is something like this. This is my second portion of the graph. Let us say this is my second portion of the graph. These two graphs are equal, exactly equal. So this is a mirror image. This portion is exactly mirror image to the second portion. So means this is symmetric. Symmetric at the, what I can say is, this graph, this normal distribution graph, we should be symmetric at the average mean value. That is one characteristics of the normal distribution. Okay. Second normal distribution characteristic is, in case of the values which are normally, this is the number of values distributed normally. Okay. The mean, median, and mode, all values are the same. It means your data set is in such a way that mean value is a median value and mode value all are the same. Mode. So what is the mean average? Median means the middle number. Mode means the maximum repeated numbers. So here in case of normal distribution, these values are distributed in such a way that the average of these numbers, median of these numbers, mode of these numbers, all are the same. There is no difference. All are exactly the same. And the second is, it's a bell shaped curve. It's a like bell shaped curve. And third is, like it's always the short curve is symmetric at the mean value. This is symmetric at the mean value. Okay. So and next fourth is okay. Fourth is here. So I'm going to say include the standard deviation. Standard deviation is having some special. So the distributions are like this. See, mu minus here the sigma means standard deviation. So mu is, let us say, sigma is, let us say, sigma value is equal to say some 50. Okay. So between like 1150 to now let's say 150. Yeah, 150. Let us say. So mu minus sigma. What is means? Mu value is equal to 1150. That's what we discussed. 1150 minus 150. That is equal to 1000. And mu plus sigma, that is equal to 1150 plus 150. That is equal to 1300. So it means this is my 1100 or 1000 indication. This is my 1300 indication. In between, there are so many values in this data set which are ranging between the 1000 to 1150. So those values are going to take 34% of the entire data set. The values between the 1000, the values between 1000 to 1150, there are so many values present. The values can be anything between like 1001, 1020, and etc. etc. So many things will be there. I don't care about what is the value, but any values that is ranging from 1000 to 1150, those values are having 34% of total data set. 34% means, let us say, there are some three values present in between in this data. Let's say 1110, so 1010, 1020, and 1040. These are the only three values present in this data set, which are ranging from 1000 to 1150. Okay, these values is repeated in this data set in such a way only just these three values are 34% of the occupancy. These values are occupied in this data set. Means if the entire data set is having 100% of their values, 34% of the values are only these values. So again, the same to same concept. The values ranging from 1150 to 1300. The values can be anything. Any number of values is present. Like say, the four values are present. Let's say that 1170, 1200, and 1267, or let's say 1290, 90. Four values are present between this range, 1150 to 1300. These values are also going to occupy another 34 percentage of the data. This 34 is fixed actually. Clear? So means this is the mu value, average value of this entire data set. Average value minus standard deviation, average value plus standard deviation. So almost 68% of the data is occupied. See the number 68% of the numbers present in the data set are between this range. There are so many elements are there. 68% of the elements are present between this range, 1000 to 1300. What is the 1000? 1000 is average minus standard deviation, average plus standard deviation. Similarly, 95% of the elements present in the data set should be present between 850 to 1450. What is 850 means? Mu minus double of the standard deviation to mu plus double of the standard deviation. So means 1150 is my mu minus double of the standard. So 2 multiplied by 150 is equal to 1150 minus 300. That is equal to almost like 850. Similarly, 1150 plus 2 multiplied by 150, that is equal to 1150 plus 300, that is equal to 1450. So means between this range, this data set is having n number of elements. Out of these n number of elements, the elements ranging from 850 to 1450 are 95% of the elements are ranging between these two numbers. 95% of the elements are ranging between these two numbers. This 13.5 also fixed actually here. And again, if I take one more, let's say minus 3u, so mu, so almost 99, this is also fixed, 99.7% of the data elements, 99%, almost 99.7 means almost all data. 7% of the elements are in this data set are ranging from 700 to let's say 1600. And of course, there will be some little bit more. So let's say only some 0.3% of data is going less than 700 or greater than 1600. Let us say something like that, 0.3%, which means very, very small number of data. Is that clear so far? This is how the normal distribution. So when I say normally distributed means the data should follow all these characteristics. If these are characteristics, yes, we are good. That is a normally distributed data. And such a normally distributed weights we are going to use in this weight initialization technique. Is that clear so far? Anyone have any questions on the normal distribution? Okay. So let us take uniform distribution. Uniform distribution is something different again. Okay. Let us just take the uniform distribution. Let me copy some figure for your easy understanding. Okay. It's very easy, not that much complicated of normal distribution. It's very easy to discuss. Okay. It's very simple graph, not like a complexity of normal distribution. It's a uniform distribution. Okay. Let me write a uniform distribution. Uniform distribution. It's very simple and straightforward. Okay. So in a uniform, see here also see the values, probability density. So I'm going to draw the graph something. What is the probability density means? Forget about the formulas. Okay, here we are not much important about the formulas. Just you need to understand the concept of normal distribution and uniform distribution. Okay. If I have, let us say, I have the values, a different set of values in a big data set. I have values. Let us say values are ranging from 0 to let us say 1 or any number, as I said 10 to 20 or any number you can take. That's not a problem. I'm just taking 0 to 1 because the graph is indicating 0 to 1. Okay. So any values is fine. Okay. Any range of less value, minimum value, maximum value. In case here the minimum value is 0, the maximum value is 1. So in between I have like a lot of values like 0.22, 0.34, like 0.56, etc. So many values are there. I have prepared a list of values which are ranging. The value of each and every element will be any value between 0 to 1, or including the 0 and including the 1 also. That is what it means. I am preparing some 100 elements like that. 100 elements like that. When I can say this data set is uniformly distributed, very simple logic, uniformly distributed is, let us say these elements are containing following, let us say, values, following unique values: zero 0 and 0.23, 0.5, 0.17 and 0.36, and let us say difference is, let us say, 0.72, 0.89 and 1. So 1, 2, 3, 4, 5, 6, 7, 8. So total 8 values are there. Or let's say adding two more values, let's say 0.94 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.62 and 1. Total 10 values are there. So means this data set contains 100 elements. Each and every element between any value of these 10 values only. These are the 10 values only. So these are many times repeated. So when I can say probability, this is uniformly distributed, is these are the unique values present in this 100 data, 100 elements of data set. Each and every value should be having the same number of repetitions. So means 0 should be repeated 10 times. This value should be repeated 10 times, 10 times. So all these 10 times. So means each and every value should be repeated 10 times, are present in this list only exactly the same number. So this is a probability density. Density probability means they are present at the same, they are repeated the same number of times it is repeated. So if the same number of repetitions, the probabilities of having that number in this list is same. So that's why the same. See the same distribution. So same that contains same number of times each and every value is repeated. So let's say 0 value repeated 10 times, and 0.23, there is one number here 0.23, that is also repeated only 10 times, and 0.5, that is also repeated 10 times, 0.17, that is also repeated 10 times. So each and every value is repeated 10 times. Clear so far? That is, I am just taking some random values just to explain only this particular characteristics of the uniform distribution. Okay. So that is what the majorly, so each and every value that is present. So here also there is one more characteristics. The average of these numbers. What is the numbers? So this is not a valid numbers, but just I taken these random numbers just to explain that yes, there are numbers are uniformly distributed. Means each and every unique number in this list of elements should be equally repeated, equally present, equal number of times it is present in the list, in the data set. So mu is equal to, or mu and mode equal to 1 by A plus B. Here the A is the minimum value present in the list. B is the maximum value present in the list. It could be anything, 0, 1, minimum value 0 or maximum value 1, or it could be minimum value is, let's say 100, maximum value is 150, anything is fine. So A is minimum value is A, the max value. So I can also say, I can say half of min value plus max value. I can say something like this. This is my mu and this is my mode also. Clear so far? So here the distribution of this entire data set should be any value ranging from min to max. The value should not go below the min value. The value should not go below maximum or go beyond the max value. So the min and max value should be identified first, and between the min and max value you can ideally say a number of values, and each and every value should be present same number of times in the list. So this is my one of the characteristics of the uniformity distribution. And other is the variance is equal to 1 by 12 by B minus A square. Means I can say 1 by 12 max value minus min value of the list by square. The variance should be something like this. Of course, standard deviation is square root of this variance, means 1 by 12 max minus min square of square root. So your distribution, what the values your distribution, if these distributions, the values are following these two conditions, like min and mode are the same, mean and mode are the same, and also yeah, more the same, and variance is also this value, and like standard is this value, means that is equally the uniformly distributed data. That's what simply. So there is a formula wise I can able to characterize it, but in the meaning wise, yes, this is the one. So you can take any number of values between the min value to max value. That is your choice. What is the min value you are taking? What is the max value you are taking in the data set? All these, if you take any value between the min value to max value, each and every value are equally available in this list, equal number of times available in this list. That is called uniform distribution. It's very simple actually, rather than compared to normal distribution. Uniform distribution is very simple. Clear so far? Okay. So this is the distributions and variance, standard deviations, etc. Okay. So in for class, we are just going to discuss about how we are going to initialize our weights, okay, using these distributions, and which is going to helpful for us to avoid the risk of exploding gradient problem and vanishing gradient problem. Okay.